Hey everyone, hope everyone's having a great day today. Today we're going to talk about SI units and mass, weight, temperature, and time. We've been talking about how we use the metric system to do different experiments and take different measurements so that scientists all around the world can have the same system they use. Even though we speak different languages, we can all use the same type of measurements so that we don't repeat experiments that have already been done. And if we want to repeat an experiment, we would know exactly how to do it to see if we get the same results to check for the reliability. So first thing we are going to talk about today is mass. Mass is the amount of matter in an object. We are used to measuring in pounds, but the SI unit is kilogram. And so when you're making a measurement in science, you are going to have a mass that ends in the word gram, whether it's something really small that has a milligram or something really large that has a kilogram. 1 kilogram is about 2.2 pounds, so that's quite a bit larger than a pound. So your mass would be very different if you found your mass in kilograms rather than pounds. 1 gram has about the same mass as a paperclip. So it's not very large, and that's why the kilogram is the SI unit, because if grams were the SI unit, it takes thousands of them to equal several kilograms. Okay, 1 kilogram, once again, we've talked about kilo means thousand, so kilogram literally means 1,000 grams. So if you have 1,000 paper clips, that would be the mass of 1 kilogram. Once again, it's how much matter is in an object. So if we're talking about you as the object, your mass is made up of the amount of muscle, fat, blood, bones, organs, anything inside your body that creates your mass. So it's any matter that is inside an object. Weight is something different. A lot of people get them confused. It's kind of like when we talked about accuracy and precision. They sound similar, but they're actually very different. Weight is a measurement of force, and that force comes from gravity. The SI unit is called a newton, and 1 newton equals 0.22 pounds. Okay, so a newton is pretty small. So it's smaller than a pound. If you weigh 100 pounds, you weigh 444 newtons. So that's quite a bit. Now, it has nothing to do with mass. It's all about the amount of force that is pushing down on you. So if you were to go to the moon, there's less gravity on the moon. You guys have all seen pictures of astronauts kind of bouncing around and gliding around. Since there is less force on the moon, you would actually weigh less on the moon than you do here on Earth. We have about 1/6 the gravity. So your weight would be about 1/6 of what it is here on Earth. So it's a little confusing on weight versus mass, so I'm going to have you guys watch this little cartoon. It's pretty funny. Check it out.
Good morning, Martin.
Nigel, you look sad. What is wrong?
I'm worried about the science test today.
Have you been sleeping in class again?
Yes.
If you would lose some mass, you might have more energy and be able to stay awake in class.
I do not see how losing mass can help me. I should lose some weight.
No. Mass is the amount of matter in an object. If you lose mass, there will be less of you.
But that is losing weight.
No. Weight is how much gravity is pulling on you. If you just want to lose weight, then go to the moon.
What does going to the moon have to do with losing weight?
Nigel, the moon has less gravity.
This is getting complicated.
The moon has about 1/6 of the Earth's gravity. So if you weigh 60 pounds on Earth, you will weigh 10 pounds on the moon.
Then I would have more energy and could stay awake in class.
No.
But you said I would weigh less.
You would weigh less, but all of your mass would still be there.
All of my mass? I still do not know what you mean by my mass.
You're fat. Your mass is all of your fat.
You do not need to be rude.
Sorry. Let me try this again. Less fat is less mass. Less mass is less of you. So the gravity will be pulling on you less. This will make you weigh less.
I think I understand. If I have less fat, then I will have less mass. If I have less mass, then the gravity will pull on me less. And that will make me weigh less. Do you want to get a cheeseburger and fries before the test?
Yes. Then we can discuss Newton's first law and how mass is a measure of inertia.
So you can see it's a little bit different between weight and mass. Mass, once again, is the amount of matter you have in an object, and your mass is your muscle, fat, blood, and bones. If we were to go to the moon, that wouldn't change. You would still have the exact same amount of muscle, fat, blood, bones, and organs in your body. That would not change at all. You're still the same person. But your weight is the amount of force that's pushing down on you. Your weight would change because there's less force on the moon. So if I snap my fingers and take us all to the moon, everyone would weigh less, but your mass would still be the same. All right, next thing we're going to talk about is temperature. A lot of times when you're doing an experiment, you have to get certain liquids up to a certain temperature before you can add things to help them dissolve. Temperature is a measure of kinetic energy in particles of matter. Now that sounds really fancy, but if you break it down, kinetic energy is just how much something is moving. So basically, you're saying how fast are the particles moving. So if something is moving really slow and it has a low kinetic energy, the particles are barely moving at all, that would equal a low temperature. If the particles are moving really, really fast, running around and bumping into each other and zooming from place to place, that is going to be a high temperature. And the SI unit is degrees Kelvin. We use a Kelvin scale, which many of you have probably never heard of. You're used to the Fahrenheit scale, which we use, and then the metric scale is Celsius. But in the scientific community, we use degrees Kelvin as our form of measurement for temperature. And after this presentation, I'm going to show you a little simulation that shows how kinetic energy changes. Next we have time. Time's real easy. You guys have been telling time since you were very young. Time is just the interval between two events. The SI unit is a second. Everyone uses the same time scale around the world. We all use hours and minutes and days and things like that. So this is a pretty simple one. There's no difference between the system we use here in the United States and the system they use in the rest of the world. So if you are supposed to let something cook for 27 seconds in America, that's understandable that it's 27 seconds in Japan. There's no conversions or anything like that. We're all on the same scale with time. Rate is the amount of change of one measurement in a given amount of time. Now, a rate you guys are real familiar with is miles per hour. That just means the change of distance in an amount of time. So miles is your one measurement, that's your distance, and the amount of time is hours. It's just saying how far can you go in 1 hour. If you guys are driving on the freeway and you're going 70 miles per hour, that means you can go 70 miles in 1 hour if you kept that constant speed. Now there's no SI unit for rate. It really depends on what you're talking about. So if we're using our metric system, if we're talking about how fast a car is going, we're talking about kilometers per hour. If we're talking about how fast a sink is filling up with water, you guys all know that a large pop bottle is called a 2 liter. We would be talking about liters per minute. In other words, how many liters of water are entering that sink in 1 minute. Another rate, how many students walk by Mr. King's room between classes. If I stood outside the classroom in between during our passing period with a stopwatch and I counted the students per minute, I could see how many kids walk by my room. So rate really doesn't have a set form of measurement. It really does depend on what you are talking about. All right, so I want to go back now and talk about the temperature and kinetic energy. Okay, I said kinetic energy is the amount of movement that the particles have. And right now, you can see on the screen here, this is a solid. Okay, they're pretty close together. The particles are vibrating in place, but they're not moving around. This is what a liquid looks like. You can see liquid, the particles are a little more spread out, so they have more kinetic energy. You can see them moving around more. Some are even kind of breaking off and floating away. And then a gas has the most kinetic energy. You can see how fast those things are moving around. Now, if you want to change the amount of kinetic energy that a substance has, you just change the temperature. So I'm going to go back to our solid here, and I'm going to use water, okay, because water is H2O, so you can see the hydrogen is the orange, and then the two oxygen atoms are those little white balls on the orange thing. And I'm going to heat this up. Watch what happens when I add heat to this. You can see the Kelvin scale is up in the top. Watch them start to move now. Because I am increasing their kinetic energy, that's increasing their temperature. And I've made this into a gas by adding all that temperature. And so now these particles all have a ton more kinetic energy, and that results in a much higher temperature. If I want to make them go down, now I'm going to add ice to them. I'm going to slow down their kinetic energy. I'm going to cool them off, and you can see the temperature scale is dropping down in the top of the jar, the thermometer. Watch what happens as I cool these off. They're slower, starting to move even slower, and they're going to get so slow that they're going to basically lose all their kinetic energy, and they're going to become back into a solid. And this would be a very low temperature. You can see them all joining together. Now they're kind of just wiggling in place. That is a low amount of kinetic energy, so you have a low temperature. And if I try oxygen, oxygen is just O2, 2 atoms of oxygen. Let's do the gas to start out. It's already spread out. If I add heat, even though they're spread out, you can see now they have more kinetic energy. They're moving even more now than they were before. Even though they were a gas, they're becoming a more spread apart gas. So the more they move, which is kinetic energy, remember kinetic energy is just how much something's moving, the more kinetic energy a particle has, the higher the temperature is going to be. And you can see this very clearly. These are moving faster than they were at the beginning, and you can see the temperature had increased all the way up here. All right, guys, do the quiz on the back. Write a great challenge question. Remember, if it has only one answer, that is not a good challenge question. We want a challenge question that makes people think. We want their opinion. We want to know something in their own words. So it's got to have more than one correct answer to be a good challenge question. All right, everyone, have a great night. I will see you tomorrow.